Today, ladies and gentlemen, we're going to be talking about solving systems of equations or inequalities that come to us in word problems. The first thing that we want to do is define the variables. That means, to me, pick letters that match the subjects that we're going to be talking about from the word problems. And then write down what X is equal to, or what it stands for, or what G stands for, or whatever letter you're going to use. Make sure you write it down, because it's no fun to get to the end and then realize you figured out what G is equal to, but you don't know what G stands for. The next thing to do is set up the equations. Many times, the equations will come in standard form. But not always. Sometimes the equation might be in slope-intercept form. And sometimes you just have to translate the sentence in the word problem into an equation. Once you have written your equations, then you can either use substitution or elimination to solve your system. Then you can identify your answer. I will do a few of the word problems, and I will leave others for you to do on your own. Number 1 says, the sum of two numbers is 30, and their difference is 12. Find the two numbers. Well, I'm going to use X and Y in this case because there's no item that I need to identify the variable with. So if sum means to add, and is tells me where the equal sign is, the sum of two numbers, that is X and Y, is 30. Difference means to subtract. Their refers back to the two numbers that I'm talking about. So their difference, that is the difference of X and Y, is, there's that equal sign again, is 12. Now, I prefer elimination. You might prefer substitution. You can do it either way. I always add. I never subtract equations. I always add. X plus X is 2X. Y plus negative Y is 0. I don't need to write 0. I bring down the equal sign. 30 plus 12 is 42. Divide both sides by 2, and X is equal to 21. I then can pick either one of my equations and plug 21 in for X, and I get 21 plus Y equals 30. Subtract 21 from both sides, and Y is equal to 9. I can test this on the other equation and write 21 minus 9 equals 12. 21 minus 9 is 12. 12 equals 12. There's my check step, and I have figured out what X and Y are. The second problem I'm not going to do completely, but I want to help make sure we're all setting up our equations the same way. So I want you to pause the video and see if you can write the two equations that come from this word problem. And then I will write them as well, and we'll see if we agree. It says the sum of two numbers is 25. One number is twice the second number plus 7. What are the two numbers? Well, the first sentence is very similar to the first sentence in the other word problem that we did. Sum of two numbers, X plus Y, is 25. But the second sentence is different. It says one number is twice the second number plus 7. So does it matter if I choose X or Y for one number? No. I'm going to say X as the first number, and there's that word is right there. X is equals twice the second number. Well, the second number is Y. So 2 times Y plus 7. All right, here's a word problem that has an actual story to it. I'm assuming that you've already finished solving number 2, and you'll bring your answers to class, and we'll check to see if we agree on what x and y are equal to. Number 3 says, the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. All right, so I'm going to have E stand for envelopes and N stand for notebook paper. And my first sentence says that 3 boxes of envelopes and 4 boxes of notebook paper is a total of $13.25. I don't need to put the dollar sign into an equation. And the second sentence says 2 boxes of envelopes and 6 boxes of notebook paper cost, which is the same as is, $17. All right, now, as I said earlier, I prefer elimination. I used substitution in question number 2. I'm going to use elimination in question number 3. I am going to multiply the first equation by -2. And I'm going to multiply the second equation by 3 because I want to add these 2 equations together so that one of the variables disappears. Which variable am I going to make disappear? The E. Very good. So I multiply by -2 and I get -6E minus 8N equals -$26.50. Multiply 3 times 2E and I get positive 6E plus 18N equals $51. Now I can add the 2 equations together. Remember I said I never subtract. -6E plus 6E is 0. I don't need to write the 0. -8N plus 18N is 10N. And -$26.50 plus $51. All right, I'm going to get the calculator out to make sure I do this correctly. Is $24.50. If I divide both sides by 10, I get N equals $2.45. So because I used E and N, I know that N is notebook paper. If I just used X and Y and I hadn't identified my variables, I wouldn't know which one cost $2.45. I'd have to start all over. Since notebooks cost $2.45, I can now go back to one of my equations, doesn't matter which one, and I can solve for E. So 3E plus 4 times 245 equals 1325. 4 times 245 is $9.80. So 3E plus $9.80 equals 1325. Subtract 980 from both sides. And we get 3E equals, let's see, $3.45. Divide by 3, and E is equal to $1.15. And there we figured out how much a box of envelopes cost and how much a box of notebook paper costs. Okay, I'm not going to do all of number 4. I am going to read it and tell you which variables I'm going to use. The cost of 12 oranges and 7 apples is $5.36. 8 oranges and 5 apples cost $3.68. Find the cost of each. What am I going to use to stand for oranges? Am I going to use O? I don't want to use O because O looks too much like 0. Yes. So I'm going to use G for oranges. And I'm going to use A for apples. That's just to get you started. Okay? You write the equations and you solve for the cost of each. I'm going to let you solve this one on your own. bring it to class and we'll see if we agree. All right, graphing linear inequalities from word problems. This is not easy. This can be a little tricky, but I think we can do it. Number 6 says, suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. Write and graph a system of linear inequalities. That word inequalities tells me that I'm going to have less than or greater than signs in place of the equal signs. Linear tells me it's still going to be a line that I can graph. And since I'm going to have a less than or greater than sign, I can also do the shading. All right. I am going to use F for flour and C for cornmeal. Flour costs $1.50 per pound, so 1.5 F. Cornmeal costs $2.50 per pound plus 2.5 C. And I want to spend less than $25. Can I spend 25? No, it has to be less than 25. So it's just going to be less than 25. Notice that all the money numbers are in the same equation. All the money numbers are in the same equation. Now, one of the things about word problems is that you often have money, and the other thing you often have is a total number of things. I need a total number of 6 pounds, or at least 6 pounds in this case. So the most common equation from word problems is this total. In this case, F plus C, that's my total number of things, bags of flour and bags of cornmeal. It would equal 6 if I wanted exactly 6, but I need at least 6. So is 6 okay? 6 is okay, but more is okay also. So I'm going to have F plus C is greater than or equal to 6. All right, now I need to graph these two inequalities. F plus C equals 6. I'm going to use the cover-up method, and I'm going to figure out the intercepts. F equals 6, C equals 6. That was easy. One F and one C. If I pretend one of them is 0, the other one has to be 6. I'm going to count by ones. You can count by 2s, you can count by 5s, you can count by 10s, just as long as you count regularly. This time I'm going to count by ones. 1, 2, 3, 4, 5, 6. So I'm going to make the x-axis be flour and the y-axis be cornmeal. And my intercepts are 6 and 6. Now, am I going to connect these with a dotted line or a solid line? It's going to be a dotted line since there's no equal bar. And am I going to shade above or below this line? Well, my total has to be more than 6 if it's not exactly 6. So more than 6 is going to be up here. Less than 6 would be underneath the line. All right, I'm going to use the same process to graph the other inequality. I'm going to do the cover-up method. If C is 0, then F will be equal to, I thought I changed that to green, F will be equal to 16.6 repeating. And if F is 0, C is going to be equal to 10. So I'm going to graph these intercepts, 6, 7, 8, 9, 10. And 16 2/3. Well, I'm going to have to guess, sort of. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is about out here somewhere. And this time, this one's going to be a dotted line, and the other one is supposed to be a solid line, isn't it? Oh my goodness. I'm going to have to go back and change that. That is a solid line. Did any of you notice that? That is a solid line. All right. since we are going to pay less than $25, I'm looking for space underneath the line. Less than means to color underneath, greater than means to color above. And now I'm going to hunt for two possible solutions. Well, I see lots of possible solutions, so I'm just going to pick two. I pick this one and this one. So all I need is the coordinates of those points, and I've got my two possible solutions. 1, 2, 3, 1, 2, 3, 4, 5, 6. So 3 flour and 6 cornmeal. That's one possible solution. Since it's a linear inequality, there's lots of ways I could get what I need and spend less than $25. The other option I've circled here is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 7 flour and 4 cornmeal. You might come up with different solutions since there are so many to choose from. Tell me when you get to class. All right, here's question 7. I'll do this one with you, and then I'll let you do the last two, and we'll work them out in class and see if we agree. I'm going to do this one because I have to count the x and y axis by something other than 1. A seafood restaurant owner orders perch and salmon. Perch is $4 a pound, and salmon is $3 a pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. Write and graph a system of linear inequalities. Well, as we said last time, all the money numbers will go in the same equation. And I'm going to use P for perch and S for salmon. How about that? That makes sense. So 4P plus 3S. Oh, cannot spend more than $240. Can I spend exactly $240? Yes, I can this time. So it's going to be less than or equal to $240. And here's the other equation that happens most often, the total number of things. We want at least 50 pounds of fish. So it would be P plus S equals 50 if we were going to buy exactly 50 pounds. But we don't know that we're going to get exactly, so we need 50 or more. So that's going to be greater than or equal to. All right, I'm going to use the cover-up method again to figure out what my intercepts are. P is going to be equal to 50, and S is going to be equal to 50. If I pretend one of them is 0, the other one's going to be 50. So let's see. Perch, I'll make the x-axis, and salmon, I'll make the y-axis. Now, I need to get up to 50. I can't count by 1s. I don't want to count by 10s because I can count by 5s. I want to be able to spread it out as much as possible without needing to go on to the next county to plot these points. So I'm going to count by 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 5s is 50. And going up the salmon ladder, oh, that was a joke. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, there's our two intercepts. And I'm going to connect those with a solid line. I remembered this time. And since we need 50 pounds or more, I'm going to shade above. I'm going to shade above that segment. Notice that segments pretty much stay in the first quadrant when it's a word problem. Okay, now I'm going to do the cover-up method for the other equation. P, 240 divided by 4 is 60, and 240 divided by 3 is 80. So perch is going to be 60. Well, I know that's 50 right there, so 55, 60 is going to be right here. And 80, that's 50, 55, 60, 65, 70, 75. Well, 80s is just a little bit above there. That's okay. And I'm going to connect them with a solid line again. If I can draw a straight line, which I'm not very good at. But this time we want to spend less than $240, so I'm going to be shading underneath that line. And then it says to write two possible solutions. So I'm going to pick 2 points in between the red line and the green line. because that's where I've shaded with both colors. And you can pick any points you want. I'm going to pick this one and this one. How about that? All right, see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 3 perch and 10 salmon, but I'm multiplying by 5. So that would be 15 pounds of perch and 50 pounds of salmon. The other point is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, 6, 6. That's easy to remember. Since I'm multiplying by 5, that's 30 for perch and 30 for salmon. So I've stayed within my budget. I've spent less than $240, but I've got at least 50 pounds of fish. I got actually 60 or more in this cases. And now it's time to eat. All right, I'm going to let you do the last 2, and we'll do them together in class and see if we agree. Bring your questions.